This video is on the objective determine the critical value or critical values if it's a two-tailed test for a hypothesis test for the proportion. Right, we're doing a test about a population proportion, and this is in order to define rejection regions, right, for that critical value approach to a hypothesis test. And this is number 1. Alright, so the first video on a question related to this objective from your homework that I'm looking at. So let's take a look. Now again, if you're unfamiliar with the objective, want to see some more stuff about it, click on More Instruction, look at their videos, their examples, their notes, and hopefully those help you out. Alright, so the question is, an economist is interested in studying unemployment. He claims that the proportion of people who are unemployed for more than 6 months is not 20%. If the economist chooses a 1% significance level, what is or are the critical value or values for the hypothesis test? And we're given a nice little table here with some special z-scores. This is the z-score that would have 10% above it, the z-score that would have 5% above it, and so on. Alright, so I'm going to get to a piece of paper and start writing out some of this information. Let me get rid of the calculator here. So here the P, right, we're talking about population proportions. P this time, in this problem, represents the proportion of all people in whatever population this is that are unemployed for more than 6 months. So it's the proportion of all people, proportion of people in the population that are unemployed for more than 6 months. And as with every hypothesis test, right, we identify some claim that is being made about a parameter, right, about this population proportion. And the second sentence was, he claims that this proportion is not 20%. So P is not equal to, now 20% is 0.20 or 0.2. Alright, then once a claim or a belief is established, what you're trying to test, then you set up your hypotheses. The null hypothesis, the alternative hypothesis. The claim does not involve equality. This is not equal to. So the claim will be represented by the alternative hypothesis, right? The one that doesn't involve equality. Alright, so the claim is represented here. And then the null hypothesis and alternative hypothesis, those should be opposing statements, right? So what's the opposite of is not equal to? It's is equal to. P equals 0.20. Okay? And this is what's going to be assumed, right? You are going to assume the null hypothesis. Assume that the proportion of people unemployed for more than 6 months is 20%. And then one more thing we can tell from this. Remember, how the alternative hypothesis looks tells you what kind of a test you have. Right-tailed, left-tailed, or two-tailed. And if it's the parameter is not equal to some value, then you're dealing with a two-tailed test. Alright, and if you have a two-tailed test, that means you're going to have two critical values. Alright. Now, after the hypotheses are formed, usually then you identify some sort of significance level, which was represented by this alpha. And they said the economist chose a 1% significance level. So 1% or 0.01. Alright, then a sample would be taken and you'd get a sample proportion called p hat, right? Now remember, by the central limit theorem, for proportions, the distribution of p hat should be approximately normal with a mean of p and a standard deviation of the square root of p times 1 minus p over n. Now, I don't know what these are. I mean, p is going to be 0.2, right? We're assuming that p is 0.2. And then the standard deviation would be the square root of 0.2 times 0.8 divided by whatever n is. But we're not told what n is here. But we do have a normal distribution. And then we would find a test statistic for our sample proportion. And I'll just write that formula out again. Remember, we'd find a test statistic, which would be a z-score, right, since we're dealing with the normal distribution and not a student's t-distribution with so many degrees of freedom. This is normal. And the z-score would be, you take your sample proportion, subtract the assumed proportion, subtract the mean value p, and then divide by that standard deviation, whatever it is. Right? And again, I don't know what n is, so I can't tell you what this is here. And then we'd get into the critical values, and then compare the test statistic to the critical values and see if we're in the rejection regions or not. Okay. So now here's the part that they're asking us to do. Now I say critical values because it is a two-tailed test. There should be two of these. And what we're looking for, since we're dealing with z-scores, right, let's go to the standard normal curve, right? My horizontal line is representing possible z-scores, and we have a normal curve, right, bell-shaped, symmetrical. The z-score under the peak is a z-score of 0. Our test statistics z-score, right, would be somewhere along the line. I don't know where. We don't know numbers here except for 0.2 for p. Now the critical values, there are going to be two of them. All right, it's two-tailed. So there's going to be one over here and one over here on the same. It's symmetrical, so the same distance on both sides. One positive, one negative. And I want to set it up. I want to find these values. And you've seen the critical method before, critical value method with a test for a mean. This is really no different. I want to find these values so that the area of these regions adds up to alpha. So that means the area of this region is 0.5%, right? Alpha is 1%. So both of these have to be 0.5%, right? So 0.5% or 0.005. Same thing over here. I want the area over here to also be, 0.5% under the curve. That way they total alpha. So the z-score I'm looking for is that z-score with a subscript of 0.005 and then its opposite, right? Negative that score. Right, and this can be found from the table, right? So that table they gave us, back on the problem here, see that z with a subscript of 0.005, the z-score with 0.5% above it is 2.576. Okay, so this is positive 2.576. This over here then is negative 2.576. And here are what are called the critical values, and those mark off the entry to our rejection regions. Right? And then if the test statistic is in the rejection regions, you're going to reject the null hypothesis. And if the test statistic is between those, then you're not going to reject the null hypothesis because you won't be in these tails, these two tails, these rejection regions. But all we're asked, though, are what are these critical values? Now, we have to move this here. What kind of a test? Two-tailed, right? I want two rejection regions, like this. And then move this dot here. This is when, 1.645, this is basically when alpha is 10%. The total of these two areas would be 10%. move it to where my critical values are 2.576 and negative 2.576. Right. And you see again this area here is 0.5%, this area over here is 0.5%, making a total of the 1% significance that I want. And that's all we're asked to do. Very quick and easy. All right. Again, please read your answer explanations. And I believe that's the only part of this question. Yes. All right. So hopefully watching me do that, go over that, and watching, looking at more instruction helps you when you're doing that kind of a question on your own. And just pay attention to what kind of a test you have. Is it two-tailed, right-tailed, or left-tailed? That's going to make a big difference. All right, and thank you for watching.